Hey guys, and welcome back to my CCNA 200-301 course. Patrice is here, and in this video, we're going to review software-defined networking. Are you ready? Let's get started. Before we can delve into software-defined networking concepts, I need to explain a typical network device functions. Let's assume that we have a router. First of all, that router should let you in to be able to configure that device. So you need to be able to connect to that device somehow, like using SSH protocol, to be able to configure that specific router. And then you as a network administrator configure a routing protocol like OSPF. So that device can decide which path to actually decide about the path where the traffic should go, and then put that decision into the routing table so the router can route the traffic based on that information. And finally, routing or traffic forwarding. So the router, based on that entry in the routing table, make the decisions and forward the traffic. In networking terminology, the first part, the management part, or the component of the device that allow you to connect to that device and manage that device is called management plane. The decision-making part, filling the device to be able to make the decisions, is called control plane, and that is our main focus in software-defined networking. And finally, traffic forwarding is handled by data plane. So we have three main planes in each networking gear: management plane, control plane, and data plane. For ages, network engineers used to connect to individual devices and configure them separately, and some people still do it. But around 2010, a new architecture has been introduced, and that architecture is called software-defined architecture, or SDA. And SDNs, or software-defined networking, is based on SDA, or software-defined architecture. And it is simply means that the control plane functions that we had them inside the devices, mainly through ASICs, or application-specific integrated circuits in Cisco devices, that were hardware thingies, hardware chipsets, and move them away from that integrated hardware to a software that is called controller. So controller is nothing but a software that is centrally going to manage our networks. Cisco has introduced different SDN solutions for its different lines of products. One of them that is being used in data centers is called ACI, or application-centric infrastructure. And this is rely on Nexus 9K switches. And as you can see in this slide, instead of traditional access, distribution, and core layer devices, we have two layers, leaf and a spine. And leaves can connect to spines only, and the spines can connect to leaves only. And actually, this is a separate discussion for data center learning path. But our main focus here is that APIC at the bottom left of this topology. That APIC is our controller, and that controller manages all of these components you can see in this slide. And this will give us two main benefits. The first one is single pane of glass to manage all of these data center components. And also it provides a programming interface as well. So via APIC, you can write a program or use a third-party application to manage all of these components, or like automate many different functions you do in your data centers through this programming interface. There is three main words that is being used in SDN terminology, and you can see them in all of the SDN solutions documents. The first one is underlay. Underlay is our physical infrastructure where we have our routers, switches, and all of our hardware components and the wired connections, etc., etc. And we normally use protocols like ISIS, OSPF, and sometimes BGP to interconnect all of this physical infrastructure. And on top of this underlay, there's another layer that is called overlay. And that overlay is our virtual network infrastructure. And that is where we can connect different components logically together. And finally, fabric. And in overlay, we normally use protocols like VXLAN to provide this virtual connections between different components. And finally, fabric. And fabric is where the underlay and overlay interconnect. And this is actually, fabric is our whole picture that includes physical infrastructure and virtual infrastructure both. If we assume that controller is our central spot inside the SDA, controller can talk upstream, or it is called northbound, or downstream, or it is called southbound. Northbound is where you can communicate to the controller and send the orders. That can be through the controller web interface, or it can be through a third-party application or any application someone wrote it. And that is happening through API. And API stands for Application Programming Interface. So it is software to software communication. And even when you configure something through the web interface of the controller, your commands go to the controller through API calls. So that part is called northbound communication. That is happening through API. And that is where you send, or any application, send orders to the controller. And the next part, which is southbound, is where controller needs to make an action based on the orders it receives, and it has to apply those settings or whatever you ask controller to do on the downstream infrastructure, which is mainly our devices, our switches, our routers, or whatever we have in that SDN solution. And that part is happening through protocols like SSH, SNMP, or NetConf, and RESTConf. So this is how different components communicate to each other and can get the orders and send the orders. So you can manage your infrastructure through a SDN solution. All right, guys, this was our today's video. In today's video, we covered exam topics 6.2 and 6.3. And in the upcoming video, I'll be talking about REST APIs. I wish you enjoyed today's video and see you in the next ones.